Okay, I'm recording now.
Okay.
Do you see my screen?
Yeah, I could see your screen.
Very good. So today we are going to do a little bit review of functions that you learned in the advanced functions.
Okay.
So in advanced functions, you learned about different types of functions. For example, polynomials. One important types of functions are polynomials. A polynomial is a function f of this type or of this form, a0 plus a1x plus an x to the n. So f here is a polynomial of degree n. So in particular, we have quadratic function, which is a type of a polynomial, right? So for example, we have quadratic. So for instance, f of x equal to
X squared plus whatever.
X squared minus 2x plus 1. This is a quadratic.
Yeah.
And you have cubic polynomials and so on. Okay?
Yeah.
Okay. And one important property of polynomials is that the range of any polynomial is basically the set of all real numbers. So if you have a polynomial like this, the range of this guy, sorry, the domain, not the range, the domain, sorry, the domain. So the domain of any polynomial is the set of all real numbers. Then we have more complicated functions. For example, we have square roots or the cubic roots. In general, we have radicals. So f of x equal to square root x. So for a function like square root x, the domain is not R anymore. It's not the set of all real numbers. What is the domain of a square root x?
Greater than 0.
Or equal, so to
Greater
0.
or equal to 0.
So x in R such that x is greater than or equal to 0. That's the domain of it. Right? So in general, if you have a function who is a kind of root, if the root is even, like the square root, fourth root, sixth root, general and even number, like 2, 4, 6, then the domain is again the same thing. The set of numbers that are equal or greater than 0. But for the odd roots, there is no restriction on the domain. So if you have a function which is an odd root, like 3 or 5 and so on, so the domain would be what? All real numbers, right? So Then we have rational functions, so polynomials and then rational. What is a rational function? So you have rational function. So rational functions. So what is a rational function? A rational function when you divide the two polynomials. So a rational function is a function f of x, so that you have like px over q of x, in which p and q are polynomials. Okay? So a rational function is basically a fraction of two polynomials. In the denominator and numerator, you have polynomials. For example, you have a function like this, f of x equal to 1 over x squared minus 1, right? So whenever you have a rational function, so you have to be careful about the domain, because there is some restrictions about the denominator. What is the restriction on the denominator? Whenever you have a denominator,
It's the denominator, and it's the restriction of the vertical asymptote.
so in general, whenever you have p of x over q of x, the restriction on q, the denominator, is that q cannot be 0, right? So look at here, q. So the restriction is that q of x shouldn't be equal to 0, right? For example, in this example, you see x squared minus 1 shouldn't be 0, right? Do you follow?
Yes, I follow.
Okay, so the domain, so you have everything in the domain. For example, look at this function. So what is the domain of this function? So for finding the domain, we know that there is a restriction, and that is the denominator, x squared minus 1, cannot be 0. So now the question is, when the denominator is equal to 0?
Wait, could you repeat that question again?
So when x squared minus 1 is equal to 0,
Okay.
for what x?
Or equal to 0?
Yeah.
Wait, x squared minus 1 was 0?
Mm-hmm. That means x must be equal to either 1 or
0. Oh, 1 or 0.
minus 1. Right?
Yeah.
So x equal to 1 and x equal to minus 1 are not in the domain, right?
Yeah.
Because if x equal to 1 or x equal to minus 1, the denominator would be 0. So you have to remove these 2 points from the domain. So that means, therefore, the domain of this function f here is what? Can you tell me what is the domain then?
That x to real numbers such that x cannot equal to positive to negative 1.
Exactly. So any number except 1 and negative 1. right?
Yeah.
So in general, you know how to find the domain of a rational function. So the main equation to find the domain of a rational function is basically finding the zeros of this guy, the denominator. So you find the zeros of the denominator, and then you have to remove the zeros from the domain.
Yeah.
We have a special type of rational functions of this type. For example, you have rational function f, let me just write f, equal to ax plus b over cx plus d. And for this type of rational functions, what we need to know is what is the asymptote of this function. So we have a vertical asymptote and we have a horizontal asymptote. So in general, for this type of function, the vertical asymptote is when the denominator is zero. So the vertical asymptote is x equal to minus d over c, and the horizontal asymptote is y equal to a over c. So let me give you an example. For example, look at this function. F of x is equal to x minus 1 over 2x plus 3. So what is the vertical asymptote? So first of all, what is the domain of this function? Can you tell me?
So the domain, give me a second, x, 2 over 3.
Is everything except
Everything except
minus
3 over
3
2.
over 2. So now, what is the vertical asymptote? The vertical asymptote so the vertical asymptote is basically x equal to this guy, minus 3 over 2, right?
Yeah.
And the horizontal asymptote is y equal to, here you have 1 over 2. So once you have the vertical asymptote and the horizontal asymptote, then we can draw the graph of this function, for instance. So let's do the graph. So let's draw the graph. So imagine this is y and x. So first of all, I draw the asymptote. The vertical asymptote is x equal to minus 3 over 2. So imagine this is x equal to minus 3 over 2. So this is x equal to minus 3 over 2. This is the vertical asymptote. The horizontal asymptote is x equal to 1 over 2. So x equal to 1 over 2 is something like this. Sorry, y equal to 1 over 2. Y equal to, right? So these are the vertical and the horizontal asymptotes. Now the graph, how to draw the graph. So for instance, it's enough to find y and or x-intercept. So what is the y-intercept? The y-intercept is x equal to 1, right?
Yeah, x
So
equals to 1.
X equal to 1 is the y-intercept, for example, here. And what is the x-intercept? Oh, sorry. The x-intercept is x equal to 1. The y-intercept is y equal to minus 1 over 3. So x equal to 1 is the x-intercept. The y-intercept is y equal to minus 1 over 3. So it's like this. So these are the x and y intercepts. So the graph looks something like this. Once you have the vertical asymptote and the horizontal asymptote, you can draw the graph. You remember?
Yes, I do.
Okay. So for next time, I want you to draw. So I give you some homework. So this is your homework. So the first question is, question 1, find the domain of each function. Okay.
Okay, do I do just all of this?
All of them, yeah.
Okay.
This is the first question. And then the second question is, let me write it. So question 2 is, for each function, find the asymptotes, then draw the graph. Okay.
Okay.
So this is your homework for next time.
I just have a quick question. For
Okay.
question 2, it says to find the asymptotes of the function. Is it just f of x equals 1 over 2x plus 1, or also the ones for question 1? Hello?
Yes, 1 over 2x plus 1.
Okay. Okay.
Yeah. Is 1 over 2x plus 1 is part A. Part B is, there are two functions. F of x equal to x minus 3 over 1 minus x.
Okay, no problem.
Is it clear?
Yeah, it's clear.
Okay.
Yeah.
Now let's move on. So you do this and we can discuss it next time, on Wednesday or on Friday, for instance. Now, next, let's move to another topic. So we discuss about rational function. So another thing that you learned in advanced function was exponential functions, right? So you remember exponential functions, right? Do you hear me?
Yes, I do. I hear you.
So you had exponential functions, for example, functions of the form f of x equal to a to the power x, where a is positive and a is not equal to 1. So for example, you have f of x 2 to the power x, f of x 1 over 3 to the power x, or the most important is e to the power x. Do you know the number e?
It's it could be any number, right?
No, e is a number, is an irrational number. So e is an irrational number here. And its value is something about 2.7.
Oh.
So e is a special number, which is about 2.7, but it has infinitely many decimals. It's about 2.7. It's an irrational number.
Just like pi.
Just like pi or square root of 2.
Okay.
So you remember we have rational versus irrational numbers. So for example, pi is irrational. Or square root of 2 is irrational. Square root of 5 is irrational. These are...
spicy. Not.
Okay.
Okay.
So now, yeah, so for exponential functions, any exponential function, the domain is all real numbers. So there is no restriction on the domain of exponential function. So domain of exponential function is equal to all real numbers. And if you want to draw the graph, if f of x equal to a to the power x, if a is a bigger than 1, then it's increasing. Let me tell you. So let me draw the graph. So if a is bigger than 1, then the graph is increasing, or the function is increasing. It's like this. Y equal to a to the power x, a is greater than 1. If a is less than 1, then it would be decreasing. It would be something like this. It's the opposite. So this is y equal to a to the power x, but a less than 1. So for example, 2 to the power x is increasing, or e to the power x. So for example, this is like 2 to the power x, or e to the power x. For less than 1, a less than 1, it could be like, for example, 1/2 to the power x, or 1/3 to the power x. Okay? And something important is that we know, for instance, some important equation is that if you have a function like f of x equal to 2 to the power minus x, this is the same as 1/2 to the power x, right? So that means the graph of 2 to the power minus x is exactly the same as the graph of 1/2 to the power x, which is something like this. This is y 1/2 to the power x, which is exactly the same as 2 to the power minus x. Okay? And then we have logarithm or logarithmic functions. What is a logarithmic function?
It's the inverse of exponential functions.
Exactly. So what is a logarithm? So we say that y is equal to logarithm of x with base a. The base, we say this a is a base of the logarithm. This is equivalent to saying that x is equal to a to the power y. So y equal to log x with base a is equivalent to saying that x is to the equal to a to the power y. So for example, you have, so let me, so y equal to log x with base 2 if and only if x equal to 2 to the power y, or y equal to log x with base 10 if and only if x equal to 10 to the power y. there is one special logarithm which is called the natural logarithm. So what is the natural logarithm? And that's when you have the base equal to e, number e. So natural logarithm. So when a equal to e. So that means log x with base e. Okay.
Okay.
We sometimes write this natural logarithm in the textbook. They write it as ln. So ln means natural logarithm. It means logarithm with base e. So that being said, it follows from here that when I say y equal to ln of x, because the base is e, this is the same thing as x equal to e to the power y. Okay.
Okay.
I don't want to go too fast, so let me give you some example about logarithm.
Okay.
So let's look at some rules for the logarithm. So what are the rules of rules of logarithm is very similar somehow to the rules of exponential. So for example, one rule is log a plus log b, and here we assume that we are having same base, similar base. This is equal to log a times b. So when you add two logs, is equal to the log of the multiplication. Second rule is log a minus log b. This is equal to log of a over b. Third rule is that log x to the power r is equal to r times log x. In particular, you have log of 1 over x equal to minus log x. Okay, so these are some important properties of logarithm. Then the next question one might ask is, what is the domain of the logarithm? And how the graph looks like? So you remember what is the domain of a logarithm?
I forgot. It's a bit rusty.
So if you have like f of x log x So the domain of f is the positive numbers. Domain of f is the set of x in R such that x is positive. And the graph of a logarithm looks like this. Let me also draw the graph. The graph, if the base is greater than 1, for example, ln, let me do the graph of ln. Or this is also the same as log with base 10, for example. So this is y equal to log x with base a is greater than 1. So for example, y equal to ln of x. Remember that when ln is the natural logarithm, ln is basically logarithm with base e. So the graph of ln of x, which is the natural logarithm, looks like this. The graph of log with base 10 also looks the same. And something very important is that log of 1 is always equal to 0. The logarithm of 1 is 0. So I give you another question as a homework. Find the graph, the domain of the following functions. A, f of x equal to log of x squared minus 1. B, f of x equal to log of x minus 1 or x plus 1. And C, f of x equal to log of okay?
Yeah, okay.